And yeah, all the tools we make are available on biomedical.com. Go check them out. So first of all, hopefully you know what this is. If you don't, go check it out. This tool is running on the side. It's measuring your heart rate variability through the web camera. You kind of need to make sure there's no hairline. Control for light. Don't move for a bit. And we'll give you a measurement. It's that peak there. You're getting a strong 70 beats per minute measurement, and I feel like it's about right. Normally I compare it to the smartwatch, but then the smartwatch could also have an error, so if anyone wants to send me a chest strap or a better device, more accurate device, you're more than welcome to. And the question that we have is asking, what specific characteristic of blood hemoglobin allows for the extraction of a pulse signal from a standard green color channel in the rPPG, remote PPG, out of this tool? Essentially, and the options are, let's see if we can get it correct, because we designed this tool, so we should be able to answer it correctly. A hemoglobin absorbs green light more significantly than red or blue light. Hemoglobin, that's option A answer. Option B, hemoglobin reflects green light during peak systolic pressure. Not sure actually. And C, green light has the deepest tissue penetration among visible wavelengths. I don't think it's C. Reason being that we're looking at reflection, so I'm not 100% sure if it's not C. Let's read D for a sec. The green channel is the only one not affected by melanin levels in the skin. This is crazy, I don't actually know. We have a hint. Consider how the concentration of blood in skin vessels affects the light that the camera perceives. Concentration of blood in skin levels affects the light. Is it A? Yeah, it's A. I did kind of guess. I mean, all the options, I kind of knew it's not C or D. I wasn't sure. Yeah, so A is correct. Hemoglobin absorbs green light more significantly than red or blue light. So that's why we're extracting the green channel out of the video footage. The fluctuations in blood volume during a heartbeat cause measurable changes in green light absorption, which forms the basis of the pulse wave. And that's that wave there. So that was a really good question, brought to you by a Gemini model through Notebook LM. Should we go for another one? Did the answering the questions elevates your heart rate? If the question is too hard, would your heart rate increase? Maybe, probably. We have another question about the same tool, this one that you can see on your screen. And go check it out as well. Everything we do is available on biomedical.com. This was the last edition. This tool is turning your sound coming through the microphone into brain activation. So go check it out. Everything else we do is available on biomedical.com as well. There's another question about this tool. What is the primary function of the high-pass filter in the real-time signal amplification microscope, which is this tool? We can, by the way, change the high-pass filter settings. So it says here, yes, if you remove it, you can kind of see the change. So we get a noisier signal, do we? Yeah, when removing the high pass, and now we have this DC drift, and we can make a calculation. So the high pass was kind of important. Yeah, you see, there's no peak there. That peak at 0 indicates a high DC level. So when you enable it, it actually restarts the thing, so you can't just see it like side by side. It restarts the whole measurement. But now you see that the high cutoff, so the high pass is cutting any frequency below 0.7 hertz, so you essentially remove the DC component. So let's look at the question and try and answer it correctly. What is the primary function of the high pass filter in this tool? To isolate the dichrotic notch in the PPG waveform. Kinda, but I don't think it's accurate. To remove slow drifts, that sounds like it. To remove slow drifts goes by shadow movements or camera auto exposure. Not sure about the camera auto exposure, but yeah, these slow movements and things will generate a lot of DC. So B must be correct, but let's see. Option C, to eliminate high frequency electronic jitter and sensor noise. So no, that's what the low pass does. So it's removing everything above 3 hertz, which we don't really need. So C is not correct. D, option D, to increase the frame rate of the video feed. No. So it must be B. So the high pass filter in this application is used to remove slow drifts caused by shadow movements, so small movements, or camera auto exposure, so something in the light. High pass filters block low frequency drift while allowing the faster moving pulse signal to pass through. So that's the answer. And yeah, all the tools we make are available on biomedical.com. Go check them out.